I'm Brett Altschul. I'm a faculty member in the Department of Physics and Astronomy. And what I'm going to be talking about are techniques that are useful, especially for teaching highly mathematical, highly technical subjects, especially online. These are generally smaller classes. They range from occasionally as small as just like 3 people to upwards of, in the 20, 30, 40. Some of these techniques will probably not work quite so well when you are dealing with really large classes. We have large service classes in physics and astronomy with hundreds of students. And I encourage questions while I'm talking. I mean, one of the key elements of what I'm doing is that there has to be a give and take back and forth between the student audience and the instructor when we're working on understanding some physics or mathematical material. And there's no point in the students writing something down if they don't get it, or if I've made a slight mistake in writing something down. It's important that it gets corrected so they can understand the logical flow of things. As you will see, I'm using here the whiteboard. I do use, some pre-prepared slides and videos for when I have, complicated things that I'm going to show, but using the whiteboard is an important tool, even online, because I have to use a lot of equations. For example, take something I wrote down in class just last week in 704. I'm going to write down a extended equation like this: j of x prime times n hat dot x prime is equal to 1/2 n hat dot x prime j prime plus n hat dot j prime x prime minus 1/2 n hat dot j prime x prime minus n hat dot x prime j prime. Now I write this out by hand for a number of reasons. One is just to get the students writing along with me. It ensures that, if I'm writing this down, it's going to take the students some time to absorb this. And as they write it down themselves, we know that the actual activity of writing things down is very helpful. And when they go back to do their homework, they're going to be writing down these same kind of expressions. And so it's getting used to, this is the kind of things that we're going to be working with mathematically. And then I can also further annotate what I've written here. This term, marked off here in red here, is an electric quadrupole term. Whereas the other term, I point out to my students that they can recognize this form with these vectors can be rewritten as 1/2 n hat cross product with x prime cross j prime, which is just the same as n hat cross n. And that makes this term something that they should recognize as a magnetic dipole. But the biggest reason that I use the board is if I need to annotate things in an additional way, if there are questions. If I have a pre-prepared slide, I can't go back and say, oh, here, I left out a step. Let me show you what I did so that you can see going through it. I have to draw a lot of 3D diagrams showing radiation, and it often, say, let's do a close-up of this part of the diagram so we can get what's going on. In this case, if somebody asked me, where did I get this? Well, I'd say, notice that just this term and this term are just equal and opposite. So all I've done is take this expression here, divide it into 2 pieces, and then add and subtract the same thing from each piece. Now, in order to do this online, this requires having a complete mastery of the electronic tools that are available. I normally broadcast my lectures over Blackboard, but today I'm doing it through Teams, and that makes a difference. Even though this is the very same classroom that I used when I was teaching my class this morning, I had to change the setup around today because, for whatever reason, Teams and Blackboard frame the camera differently. I had to move the camera forward several feet to give me the Blackboard, correct half the Blackboard, correctly framed the way I want it. And you have to experiment and understand exactly how loud do I need to talk? How big do I need to write in order for this to be visible, both in the real-time students lecture, because I expect that students, most of them are actually going to be watching along in real time so they can ask questions. But one of the real advantages of the online modality is that the lectures are recorded so they can go back and go through things again when they have trouble. And if they say, I didn't really understand that, they can go back and watch a 15-minute segment of the lecture again and see, how did he do that calculation? But, we need to make sure that the colors show up. I've written these things in different colors, but some colors show up better than others. I don't use green very much. It doesn't typically show up very well, especially online. And I've been doing the online delivery of various classes for about 10 years in various forms. And I said the software has gotten so much better. 10 years ago, I was creating lecture videos, and it took 2 whole days basically to make a single 45-minute video, because I would have to set up the camera, record it, see how it looked, probably record it again to make sure the video was good, edit it together. It still produced a huge file, and there was a trade-off between the video quality and making the file too large for the students to download. Now, Blackboard and Teams and a whole bunch of other software packages do that all for you automatically, but you still need to know what is the camera I'm working with, what are the conditions in the room, and you need to have that set up, at least I think you need to have it set up, in such a way as to try and encourage feedback from the students. A big part of what I'm teaching in high-level classes in physics, and this goes for a lot of other technical fields, is you're trying to give students a toolbox of techniques they can use for solving problems that they may encounter in realistic situations. For me, I'm trying to teach them a number of techniques that they may use if they have some kind of problem in electromagnetic radiation or quantum mechanical scattering. But the same general strategy exists if you're teaching like chemistry or something, and you want the students to have a big toolbox of potential reactions that they can use for, say, synthesizing a compound. And that means that I have to show them a lot of different ways that they can apply these techniques and how these techniques can be applied in successively more complicated ways. And it's important to get the students to be able to recognize when a technique that they have already started to see how to use can be applied more broadly to a new class of problems. So I may write something down like, say tell them that we are looking at the longitudinal magnetic field in a waveguide, and it is going to obey an equation that looks like this. And I ask them, are we likely to be able to solve this? And this example is chosen very carefully so that I can say, now, wait a minute. if we don't see how to solve this, you can cover up these terms, and that's a problem we've done before. That's the solution of the Laplace equation. And so I get the students say, oh, well, if we want to solve the Laplace equation, we would use separation of variables. And generally, I can get one of the students to come up with that. I said, yes, write that on the board so they'll all see it and remember. Separation of variables. And so develop a new method, a new problem that is similar to an old problem, and get the students to feedback what is the method of solving it. They say, okay, separation of variables, so that means we're going to use some function b0z of x and y. It'll be some function of x of x, times some function y of y. And then we know how to solve these things. We say, okay, plug this in. And for a simple equation like this, I can tell the students, plug it in, what are we going to get? And at this point in the class, the students should be prepared to plug this in, and after a minute say, okay, the separated equations are going to look like this. Especially online, it is important, or I find it's important, to introduce lots of breaks in me talking where I solicit feedback, sometimes just needing to know, are there any questions? Do you need me to explain more where I got this equation from? But as frequently as possible, soliciting specific feedback in a way to try and draw the students who are generally attending remotely these days into interacting and say, oh yeah, this is, keep them engaged. So say, what's technique is here? And if they separation of variables, they say, okay, great, plug that in, tell me what you get. If somebody gives me a different technique, says, well, why don't we use the method of images? Then say, well, that's an interesting question. You could, in principle, use the method of images, but it would be much more complicated. So what is another method that would be more likely to yield a practical solution? And so at every stage in this, it's important to draw the students in and ask them, what can we do to advance the calculation further using the kind of techniques that you already know? And so that is basically how you draw them in and keep them engaged, keep them writing down things that they understand, and how we keep them, and so that they learn how to apply existing techniques to more and more complicated problems, leading up to being able to look at these kind of problems they might encounter in research. And this equation like this comes up all the time in signal transmission, for example, and say, hey, I know how to do that. It's just a slight generalization of what we've done before. But these are the key elements that I wanted to emphasize in how I teach these technical and highly mathematical upper level courses, especially online.